Okay, so 3-1, constant rate of change. And by the way, chapter 3 is all about graphing and slopes and lines and stuff like that. Okay? So you can look through it. But constant rate of change is what we're talking about. So constant. Raise your hand and tell me what constant means. This is not a trick question. Allie? Constant. Are you sure?
Well, it's like the same.
Yeah. The same. What else, Crater?
Same throughout time.
Same throughout time. Same doesn't change, right? Constant. It's not going to change. All right. So constant rates don't change. Here we go. We have this thing called linear relationships. And this, again, happened in 7th grade. And this is when we have straight lines on our graphs. There's a really long definition that goes with that, but I'm going to save you the time. If you want it, you can look in the book. But it's basically when you have that straight line on your graph. Okay, that's linear. Linear for line. And then the constant rate of change thing, what that means is that the rate of change between 2 points on a linear graph, so 2 points on a line, they're the same, okay? It's the constant is actually like the rate. How is it changing over time? So the constant is the rate of change between 2 points on a linear graph. Now, I know we've done points. We've done 2 points. We've done graphing. You guys have done a lot of like graphing pictures and just graphing and plotting points. You've done this in elementary and 7th grade. So that part will be familiar to you guys. The points and the x and y coordinates, stuff like that. Okay, so here is example 1. I'm going to give you guys a minute to write this all down, and then I will talk about it. table of values. You guys have seen these tables before. I just labeled them X and Y. So all the X's, you have 3, 6, 9, 12, and those are all going up by 3. That's why I put the plus 3. And then the Y values, the 170, 140, 110, see those are going down by 30. So I put negative 30. So far so good on the table? That makes sense, right? Going up by 3 on the left, going down by 30 on the right. Now how we write these is we always write the change in Y over the change in X. So this little triangle means delta. Have you guys seen this sign before?
I've heard that one.
Okay, good. So delta means change. It's Greek, right? So this is the delta Y over delta X, which means the change in Y over the change in X. And Y always goes on the top. Y is always the numerator. Okay? If you mix those two up, you'll have a wrong answer. And so this is the negative 30 over 3, and when you simplify, that's negative 10. So the constant rate is negative 10. So it's the change in Y over the change in X. Any questions on that? No? You're so smart? Okay. All right, sometimes the table is written this way, like more horizontally. And so I just want to show you that X, sometimes it's not labeled X and Y, like this is in degrees Celsius Fahrenheit. So the X is always on the top on this one. So I put a little X and Y for you. So this is Celsius. When it's 0 Celsius, it's 32 Fahrenheit. You might know this from science. Hopefully. When it's 5, it's 41. When it's 10, these are all degrees, okay? So as my Celsius changes, goes up by 5, my Fahrenheit goes up by 9. Did you guys learn this formula in science, this 9/5 thing? Some people did. Some people did and then they forgot. Or some people just copied it from their book and never paid attention, right? Has anyone lived somewhere where they use the metric system? Just you? So you know Celsius?
Yeah.
Yeah.
If it's like Celsius or Fahrenheit, does it matter like which one is X and or Y?
It doesn't matter which one's X or Y, but this is just a good example to show you so that, because we know the formula is 9/5 when we're converting, but it's always, when they write it this way, X will always be on the top and Y will always be on the bottom. And that part matters because we put Y over the X in our formula here. Yeah. Did you have a question about Fahrenheit, Celsius?
I would ask a question. For Celsius, freezing point is 0, right?
Yes.
And then
32 is Fahrenheit.
why do they make Fahrenheit freezing point 32? That just
Because
makes no sense.
you want to know the truth?
Yeah.
Have you ever looked at the metric system and noticed that it's all in hundreds and thousands and
Yeah.
very simple things? And everyone in the world uses metric except us? Why do you think that is?
Because we wanted our own stuff.
That's right. We wanted to be different. Yeah.
Also know a little bit more about that.
You do? What?
We didn't want to change over to the metric system because of football.
Because of football?
Didn't we
Because of the
change over
meters,
once?
they got too
Wait,
confused.
I want to know. Okay, so, but we started with metric and then we didn't
And then we went
keep
to
it
customary.
because of football.
Yeah.
Yeah.
No. We went to
What did we-
customary because of
We learned that in
being-
science.
Yeah, we
okay.
learned it in science.
Oh, I heard this story. Okay, and we were gonna switch back, but they said no because then we have to change the yardage.
Yeah.
Yeah, and then we didn't, and then we tried to change back to metric, but
Yeah.
football players were getting confused with feet and meters.
Because football players can't do math. Oh, who plays football in here? I'm just kidding. Football players can do math. All right, that's a good story. I like it. I don't know if it's true, but
It is.
I think it's
it was on the internet, so it must be true.
Yeah.
Yeah.
there was a whole like.
All right,
thing about it.
a TED talk on it. I bet.
Must,
Okay, was it a TED Ed?
No.
Who showed you this?
Mr. Marquez.
Then it was TED Ed. Was it a cartoon?
No.
Oh, then it wasn't.
It was on the news.
It
Fascinating.
was in like a news thing.
Yeah.
All right,
His favorite.
let's move on. So that's the 9/5. Next one. Shh. This is kind of important. This is a little bit of review from 7th grade. Besides, you did this in 7th grade. We just didn't call it slope, just so you know. But the graph will be linear but not proportional. So this can happen, okay? I'm going to show you when this happens. When you can have a straight line graph, but it's not proportional. Who knows what proportional means from 7th grade math? Jordan?
Doesn't it mean like equal?
Sorta. Connor?
Like the same.
The same, sorta. No. Proportional has ratios. So it has the same ratio. Good. All right. So in Math 7, you learned that for something to be proportional on a graph, it had to go through the origin, which was 0, 0. Remember that? Had to go through 0, 0, and then also have that constant. So it had to be a straight line going through the origin. You should have learned that in Math 7. All right, if I was your teacher, you learned that in Math 7. Uh-oh.
No, just
No one. Darn.
Miss Garner.
All right, here's Math 7 real quick. For a line to be proportional, it has to go through 0, the origin. You know 0, 0 on the graph? And it has to be a straight line. If it's a straight line but doesn't go through 0, it's not proportional. So sometimes if you could just look at a graph, you know the answer. But do they always just give you a picture of a graph? No. They give you points, or they give you a table or a chart. All right, so here is an example. If you look above, right, these numbers came from here, right? And see how this is going up 5 and then up 9? That's linear, right? But if I start putting these Fahrenheit numbers over Celsius, do you see what's happening? This ratio is 8.2. This one's 5. This one's around 3.9. Are these all the same numbers? No. So this graph right here would be linear if we graph it, but not proportional. Because when Celsius is at 0, Fahrenheit's at 32. And I need them to both be 0 to be proportional. They need to both start at the same value there at 0. That was a little bit of Math 7. So we can always get the linear value here, but to check proportionality, we have to put some numbers, like at least 2, compare 2 numbers, okay? It's a good idea to compare 3 in case you make a mistake in your division. But really, all you have to do is compare 2. All right, so since the ratios are not the same, so that means like 41 to 5 does not equal 50 to 10, okay? Since the ratios are not the same, the relationship between Fahrenheit and Celsius is not proportional. So that's what I just said, and that's what it is in words, okay? If you need to comment on anything being not proportional on a test or quiz, you could say something like that. Just change your units, whatever it was. Maybe it's time and temperature, or passing and yardage if you're doing football, I guess. Batting and home runs. Since World Series. Since the Giants are going to win. Tonight? It's tonight, right?
I don't really.
Who's a Giants fan?
I don't.
You mean 49?
Haha. Who's like the biggest Giants fan in here? Raise your hand. The big Billy Page, you are? Who is?
Emily.
Who? Amanda, you are? You are?
I'm just kidding though.
Okay, party at Amanda's house tonight. And Brielle's. Brielle, you're a big Giants fan? Hey, and by the way, this is on YouTube. Party at Brielle's house tonight.
Woo!
And her address is... No, I'm just kidding, Brielle. All right, so again, since ratios are not the same, the relationship between Fahrenheit and Celsius is not proportional. These ratios are not the same. Any questions on that? I'll take Giants comments later. But
No, it wasn't. I was gonna ask if this was the end of the.
no, it's not.
Go Cardinals.
All right.
So I just throw that out there.
They already lost.
No random people.
All right, next page. Shh. Just remember it's still recording you and your silly banter. All right. Here's the last example. This is if you get this in a graph. Like the other ones were tables, right? Sometimes you have a graph. So I will give you the whole picture here. I'm gonna move it a little bit here. All right, so I have a graph, and let's just say this is skydiving. We'll say it's skydiving. So you start at 6,000 feet, and then eventually you hit the ground, right? Okay. So, well, you land gently.
You land safely.
Sure.
Okay.
That's your safe.
So let's say CJ. He looks really brave. He's jumping out of a plane, but the wind is blowing him. The wind is blowing a little bit, so you don't land right under the plane, right? You land a little bit over. That's what's happening, okay? He's really super brave. Awesome, CJ. All right. So,
I know where you live.
is this graph linear?
It's creepy.
Shh. Raise your hand if you think it's linear. Yeah, it's a straight line, right? What is the constant here? The constant. That's what we need to know. Okay? So, yes, it's linear, and this is how we find the constant. We start at 6,000, and we go to 4,000, and we go to 2,000. That's a change of what? Each time. You're going down 2,000, right? That's what I wrote over here. And this side, we go from 0 to 6, but each time we go up 2. Do you see that? So this is negative 2,000 because it's going down, or CJ's going down 2,000 feet every 2 seconds, let's say. Okay? And so we have this negative 2,000 over 2, and that's how we get negative 1,000. Now this is super important, and for some reason, we miss this all the time. But did you notice how this is negative?
So you're saying
Negative. And look at the graph. The graph's going down and to the right. Do you see it going down and to the right, everyone? If you see a graph going down and to the right, it's going to be negative. If it's going up and to the right, it's going to be positive. Okay? So just remember. And then the best way to figure out is if your line's negative or positive is to put it in a real world thing. Like, this had nothing on it, but I said, oh, skydiving starts here and goes down here, right? So we know we're going down. That has to be a negative slope, okay? Any questions on how I got that negative? We all see it? Okay, good. I will get half of my class, half of my students, they will still write this as positive for some reason. Maybe because you're not paying attention. But
They're flying up.
maybe.
Gravity shift.
All right, so here's what you're going to do. We are going to do a second set of notes, but first you are going to practice in your book. It's only 7 problems. Okay, so you're going to practice these 7 problems on page 175. Okay, and I'd like you to finish in about 10 minutes. And then we'll go on to the next section of notes. Okay? Now, if you finish early and you feel like you can move ahead onto the next section, good luck with that. Because I haven't taught you yet. Okay? So 10 minutes, work on that.